Hi dear friends and viewers, welcome back to our channel Vinay Kumar Basics of Physics. This is the right place to learn physics. Dear friends, in this video we are going to discuss about the factors which are affecting the velocity of sound in air. The factors affecting the velocity of sound in air. Let's go for that. In this video we are going to discuss some previous questions and some examples related to the same topic. Watch the video till end without any escape, then only my content will reach us to you. Let's go for that. Here, factors affecting velocity of sound in air. So here, velocity of sound in air, velocity of sound in air is given by the formula V is equals to under root of gamma P by rho. V is equals to gamma P by rho. Here gamma is the ratio of specific heats and P is the pressure and rho is the density. In this case here, velocity of sound V is independent of pressure. It means that when the pressure is increases, then there is no change in velocity. Pressure do not affect or do not influence the velocity of the wave. Why? Because when pressure increases, then density also increases in the same manner. Clear? Gamma is constant. When P increases, in the same amount of what amount of the pressure is increased, with respect of density also increases. That's why there is no effect on the velocity due to the rise in pressure. That is the first point you have to remember. What is that? When the pressure is increases, there is no change in velocity of sound in air, because when pressure increases, with respect to that density also increases. That is the first one. And the second one is here, velocity of the wave. Velocity of the wave is directly proportional to the absolute temperature. The velocity of sound is directly proportional to the under root of or square root of the temperature. Why? Because from this formula we can write V is equals to gamma P by rho. So if you can take the ideal gas, 1 mole of ideal gas, what we write? PV is equals to RT. From that what we can write? P is equals to, we can write like this, RT by V. You can substitute here V is equals to under root of gamma, P means what? RT by rho into V. So what we know, density is equals to mass per volume. Then mass means what you have to write? Rho into volume. That's why here we can write V is equals to under root of gamma RT by M we can write. So here obviously here gamma is the constant and R is the universal gas constant and M is the molecular mass. So all are constants. Then obviously what we write? V is proportional to root T. So according to this formula, then obviously what write here? V1 by V2 is equals to, we can write of T1 by T2. This is the relation between the velocity of sound to the temperature. Clear? And we can write the same thing here. If you can convert the temperatures into the degree Celsius, then the same equation can becomes as V1 by V2 is equals to under root of here we are going to change into the Kelvins to the degree Celsius by 273 plus T2. So this is the another equation we are going to use in the same numericals. If we have another formula, it is there. Let V naught is the velocity at the temperature of 0 degree Celsius. Now what it is the temperature at the T degree Celsius? That is the formula we have, that is should be given by Vt is equals to V naught of 1 plus T by 546, T by 546. So this is the velocity of sound at temperature T degree Celsius, and what is V naught? Velocity at the temperature 0 degree Celsius. Then the equation should be written as 332 degree Celsius of 1 plus T by 546. So this is also important formula that should be helpful to the numericals. Now let's discuss the what is the relation between density and velocity of sound, and how the humidity in medium can affect the velocity of sound, and how the wind can affect the velocity of sound. Let's discuss here. The first thing is what we know here, effect of density, effect of density. So effect of density. So what we know, velocity of sound in air is given by under of gamma p by rho. Clear? So when pressure and gamma is constant, simply what write? The relation between these two is as inversely proportional. Velocity of sound is inversely proportional to the square root of the density. Sound is inversely proportional to the square root of the density. In the same manner, we have effect of humidity. Effect of humidity we have to discuss. So for that simple logic, it is that when humidity increases, then volume decreases. When humidity increases, volume decreases. When volume decreases, density is increases. You have to remember, if the humidity increasing of humidity, then volume is decrease. Why? Because rho is equals to mass per volume. When humidity is more, the molecules are very close, then volume is decrease. When volume decrease, density increases. When density increases, here velocity of sound is increases. Clear? Because the molecules are very close to each other and they can transfer energy one molecule to the another molecule very soon. That's why velocity of sound is increases when the humidity is more. Clear? That's why here what you have to say, therefore velocity of sound should be more in rain compared to the velocity of sound in dry air. Clear? So you have to understand very simply, effect of humidity. When humidity is more in atmosphere, volume is decrease. When volume decrease, density is increase. When density increase, velocity is increase. That's why velocity of sound more is in rain compared to the velocity of sound in dry air. So this is the effect of. Similarly, now we have to discuss the effect of wind. Effect of wind velocity on velocity of sound. Let's see here what it is. Effect of velocity of wind on velocity of sound wave. For example, here one speaker is there. This is what loudspeaker generating some sound like this. Some waves are generated. Clear? So that sound here, one listener is there here. This is one loudspeaker and he was the listener, and the wind is in velocities in this direction. Wind velocity is in this direction. So here when the loudspeaker releases the sound and that should be listened by that particular observer, it means that here the sound is traveling in this direction. Sound is traveling in this direction. Here simply we are going to write here the velocity is v. The velocity of sound, it is what? V here. And similarly here the velocity component of the wind is here w cos theta. W cos theta. Therefore the resultant velocity of wave should be given by the algebraic sum of velocity of sound and component of velocity of wind. Clear? Are you understand this one? Here there is one loudspeaker is there. That should be released some sound waves. Clear? Those sound waves are moving towards the one observer. It's very clear. But the velocity of wind, it is there. That should be in this direction. Clear? When the velocity is in this particular direction, the wind always tries to brings the medium also in that direction. Clear? The wind must be tries to brings the medium particles in the same direction. Then here if it is the resultant velocity of wind, and that should be divided into two components, one is w cos theta and one should be here w sin theta. Then the resultant velocity of the sound wave should be is written as algebraic sum of velocity of sound wave coming from where? S, loudspeaker source, and w cos theta. What is w cos theta? W cos theta is the velocity component of wind, horizontal velocity component of wind. The algebraic sum of these should be gives the resultant velocity of the wave. Clear? So this is the effect of wind on wave velocity. Clear? And next thing is here, what about the effect of frequency and wavelength? Frequency and wavelength. Even though the waves are having different wavelengths and frequencies, but the waves are moves with a common velocity, same velocity, 332 meter per second or 340 meter per second. They should be moves with the same velocity of sound. Clear? That's why what you have to say, velocity of sound wave is independent of frequency and wavelength. So these are things you have to remember. What are those things here? The factors affecting the velocity of sound. How many here? The first thing is pressure. The velocity of sound is increases or decreases. That should be affected by the few factors like pressure, like humidity and wind speed and temperature, like that. So among the first one is what? Here pressure. The velocity of sound is independent of pressure. Why? Because when pressure increases, density also increases. That's why the pressure is never affect the velocity of sound because of density rises. And second thing is what? Velocity of sound is directly proportional to the square root of temperature. V1 by V2 is equals to under of T1 by T2. And third one, velocity of sound is inversely proportional to the square root of density. And fourth one, when in the atmosphere moisture is more or humidity is more, then volume decreases, density increases. When density increases, velocity of sound also increases. Simply what you have to say, humidity is proportional to the velocity of sound. And next thing is what? Effect of wind speed or wind velocity. When the wind is tries to bring the medium particles in particular one direction, then the resultant velocity should be written as the sum of the velocity of sound and velocity component of the wind velocity. So these are the things you have to remember. Now So we will discuss about some previous problems which are given in the exam. Let's see one previous question asked in the JE 1999. Let's see that the ratio of the speed of sound in nitrogen gas to that in helium gas at 300 Kelvin is. The ratio of speed of sound in nitrogen gas to that in helium gas. So simply what you have to find out, ratio of speed of V1 by V2. Here V1 is what? Nothing but nitrogen, and next one is what? VH. The ratio of speed of sound Vn by Vh, we have to find out it. So what we know, V is equals to under root of gamma P by rho. Already what we know, PV is equals to RT. From that P is equals to what, right? RT by V we can write, and V is equals to gamma RT by V into rho. Then what right here, V is equals to under root of gamma RT by M. This is the formula we are going to use. Clear? So that's why here simply you can write Vn by Vh, Vn by Vh. So here R is constant, T is constant, because he was given T is equals to 300 Kelvin. It is common for both gases. Here T is constant, R is constant. Then what right? V is proportional to gamma by M. Then Vn by Vh is equals to what, right? Under root of gamma N by gamma H into M H by M N. That is the formula we are going to use. Vn by Vh is what? Under root of gamma N by gamma H of here inversely proportional as mH by molecular mass of hydrogen by molecular mass of nitrogen. Then we can write Vn by Vh is equals to gamma 1 by 5, 7 by 5 and 5 by 3 into molecular mass of helium is what? 4. Molecular mass of nitrogen is what? 28. Then what did here? So it's simply 7 by 5 into 3 by 5 of 4 into 4 by 28 we can write, and everything is under root. Clear? So what right here, 4 ones are 4 sevens are, again 7 cancel. Then what you get here, 3 by 25, and what it is, root 3 by 5, root 3 by 5. So therefore Vn by Vh is equals to what? Root 3 by 5, root 3 by 5 or root 3 by 25. So among the options, third option is another problem. It was given Neet exam in 1993. The temperature at which the speed of sound becomes double as was at 27 degrees Celsius is. The temperature at which speed of sound becomes double as at 27 degrees Celsius. The temperature at which the speed of sound becomes double as was 27 degrees Celsius. So velocity of sound V1 is a degree Celsius of 27 degrees Celsius. Clear? And this velocity is going to be double. V2 is equals to what? 2V1. For what temperature he was asking? For which temperature the velocity of sound is going to be double? That is the question here. Already what we know, V is proportional to root T. V is proportional to root T. So then what right here, V1 by V2 is equals to under of T1 by T2, T1 by T2. Let's see one previous question asked in the JE 1999. Let's see that the ratio of the speed of sound in nitrogen gas to that in helium gas at 300 Kelvin is. The ratio of speed of sound in nitrogen gas to that in helium gas. So simply what you have to find out, ratio of speed of V1 by V2. Here V1 is what? Nothing but nitrogen. And next one is what? VH. The ratio of speed of sound. Vn by Vh, we have to find out it. So what we know, V is equals to under root of gamma P by rho. Already what we know, PV is equals to RT. From that P is equals to what, right? RT by V we can write. And V is equals to gamma RT by V into rho. Then what, right here? V is equals to under root of gamma RT by M. This is the formula we are going to use. Clear? So that's why here simply you can write Vn by Vh. So here R is constant, T is constant, because he was given T is equals to 300 Kelvin. It is common for both gases. Here T is constant, R is constant. Then what, right? V is proportional to gamma by M. Then Vn by Vh is equals to what, right? Under root of gamma N by gamma H into M H by M N. That is the formula we are going to use. Vn by which is what? Under root of gamma N by gamma H of here inversely proportional as mH by molecular mass of hydrogen by molecular mass of nitrogen. Then we can write Vn by Vh is equals to 7 by 5 and 5 by 3 into molecular mass of helium is what? 4. Molecular mass of nitrogen is what? 28. Then what did here? So it's simply 7 by 5 into 3 by 5 of 4 into 4 by 28 we can write, and everything is under root. Clear? So what right here? 4 ones are 4 sevens are, again 7 cancel. Then what you get here? 3 by 25, and what is root 3 by 5? Root 3 by 5. So therefore Vn by Vh is equals to what? Root 3 by 5. Root 3 by 5 or root 3 by 25. So among the options, third option is the correct one. Let's see another problem. It was given in JEE 2000. Very easy one. Two monoatomic ideal gases 1 and 2 of molecular masses M1, M2 respectively are enclosed in separate containers kept at the same temperature. The ratio of the speed of the sound in gas 1 to the gas 2 is given by. Two monoatomic gases 1 and 2. Two ideal gases are there. They are the monoatomic gases 1 and 2, and they have molecular masses M1 and M2. M1 is the molecular mass of first gas and M2 is the molecular mass of second gas. Are enclosed in separate containers. So both containers are there. One should be in one container, and they should be maintained at the same temperature. They should be maintained at the same temperature. The ratio of speed of sound in gas 1 to the gas 2. So here V1 is the speed of gas 1, clear, and V2 is the speed of gas 2 in another container. So what we have to find out? We have to find out the ratio of V1 by V2. That is the question here. And what was given? M1 is the molecular mass of first gas. M1 is the molecular mass of gas 1, and M2 is what? Molecular mass of gas 2. So already we know formula is what? V is equals to under of gamma RT by M. So here T is given, what it is? Same temperature. T is same for both, and here now R is the constant and gamma. Both are here monoatomic gases. For monoatomic gases, gamma value is 5 by 3. So it is constant here. Then what did here? V is proportional to under of M. Then what did here? V1 by V2 is equals to under of M2 by sorry, capital letters m2 by m1. So here already what was given, v1 by v2 is equals to 100 of m2 is what, molecular mass of second gas, and what is m1, molecular mass of first gas. So it was given in terms of small letters. That's what I have read here. Instead of capital M2 we have to write small m2, and instead of capital M1 we have to write small m1. That's why here the ratio of velocity of gas 1 to the gas 2 is what, 100 of m2 by m1. So second option is the correct one. So dear students, if you can understand what is the concept in this video, then like, share, comment. So dear students, if you are expecting more videos from my channel, please support my channel and share my channel. Thank you for watching.